Hello, this is Stephen DeMarney, and today we're going to be learning about resistors. Now here is a typical resistor that we would use for our hobbies, and it's got long axial leads, which works good for going into our solderless breadboard. And I've got another example here. I've got a variable resistor. And you can see on top it's got a little slot where you can put a screwdriver. So this is meant for PC board, printed circuit board mounting, or it can go into our experimenter sockets. You can see there's 3 leads on the bottom there, and if I turn it around you can see there's some printing telling us the size of the resistor, and what's important for us is the 20K. So this is a 20,000 ohm variable resistor. Now another example of resistors that I have is on the Arduino Uno R3 board. And these are resistors that aren't so practical for us to use for hobby work, but it's a typical resistor that you'll find on most commercial and industrial electronics. So if you took apart your computer or whatever, you would find surface mount devices. So I'm just going to point out a couple surface mount resistors. So here is a single surface mount device resistor, and this one happens to be 10,000 ohms. And then just above it is another resistor, but this one is a resistor array. So in one package they actually have 4 resistors, 1, 2, 3, 4, and these ones happen to be 1,000 ohms each. So those are a couple examples on the Arduino Uno board of resistors. Now we're looking at a few resistors that I've put onto this experimenter socket or solderless breadboard, and I'm just going to show you about color codes. Now you can notice that each one of these resistors has color codes, and we can see that there's 4 bands of color on each of these resistors, and this is the most common type of resistor that we will use for our robot building and other electronic circuits. So, but to know what the meaning of these color codes are, we need to consult a color code chart, or online you can find tools where you can enter the colors and it will give you the value of the resistor. So just briefly I'll try to explain the order of the colors. On the one end we typically see, which would be the last, what we call the last color band on the right hand side, is typically gold or silver or no color at all, and that's the tolerance band, and that will help us to figure out which is the first digit, which in this case is brown, and then I've got black, and then green, and then gold. And we're going to take a moment and take a look at a chart which will tell us what these colors mean, and then we'll come back and look at these resistors again to read what their values are in ohms. So here is a resistor color code table I made on the computer, and it helps us to be able to read the color codes of the resistors. And as you can see, each color represents a number. Black is 0, brown is 1, red is 2, orange is 3, and so on. And in our case, with four banded resistors, the first 2 numbers are read directly using this column, and then the third band on our resistors is a multiplier. So in the case of black, we wouldn't add any zeros. We just multiply by 1. in the case of brown, we would add 1 0 to the number. And I'll show you shortly what I mean by that. And then the fourth band is the tolerance. And on our resistors that I'm using, they're mostly going to be gold, but some might be silver. So if we have gold on the end, that means they're plus or minus 5% tolerance, and if they're silver, it's plus or minus 10%. And if there's no marking, only 3 bands, that means it's 20% plus or minus tolerance. And that's basically the table. So you can find better tables than this and color charts on the web that will show you how to read the color codes of your resistors, but shortly I will show you how to read them with the resistors that I have. So now that we've finished looking at the chart, we will read what values of resistors we have here. So this first resistor we see is brown, black, brown, gold. And so the first digit is brown, and that's a 1. The second digit is black, which represents 0, so our first 2 digits are 1, 0. And the third band is our multiplier. So in this case, it's 10 to the 1 power, or we could just say put 1 0 on the end. So we have 1 0 0, or 100 ohms. And the tolerance is the gold band, and that's plus or minus 5%. So we have a resistor that should be 100 ohms plus or minus 5%. And just to verify that, I'm going to hook up the negative lead of my multimeter to the board here. And then we're going to measure with the ohm meter to see if we have 100 ohms. And now you see the meter is registering 97.2 ohms. And so this resistor is very close to 100 ohms, but like we said, it's plus or minus 5%. So this is a little bit lower than 100 ohms, but very close. So now let's go to the next resistor. And I've chosen a series of resistors that all start with brown and black. So our next resistor is brown, black, red, and gold. So again, our first digit is a 1, which is brown, and our second digit is a black, which is 0. So we have a 1 0, and our third band is red, which is the multiplier, and that tells us we can add 2 more zeros. So 1 0 and 2 more zeros, so we have 1,000 ohms. Or 1,000 ohms is sometimes also called, for shorthand, 1 k ohm, which is 1,000 ohms, or 1 kiloohm. So now we'll measure with the meter, and here we see we're reading 0.990 k ohms on the meter. So again, we're very close. If we rounded that off, we would be 1 k ohm. So now let's move on to the next one. So the only difference in the next one is the third band is orange. So that tells us we have another 0. So we have 3 zeros. So we've got 1 0 and 3 more zeros, so that's 10,000. So this should be 10,000 ohms plus or minus 5%. And there we read with the meter, we've got 10.12 k ohms, which means 10,120 ohms, or 10.12 kiloohms. Now our fourth resistor, we've got brown, black, yellow, gold. So again, we've got a 1 and a 0, and then we've got, this time, 4 zeros. So this time we should have 100,000 ohms. So let's measure and see what we have. Okay, so it's not quite 100,000, but it's 97.7 k ohms or kiloohms. So we've got 97,700 ohms on the meter, and there it just changed to 6. So very close to 100,000 ohms. And then our last one, we've got brown, black, green, gold. So this time we have a 1 for the first digit, a 0 for the second digit, and then our multiplier, we have to add 5 zeros to our number. So we've got 1 million ohms, or it's also called 1 megohm. And we'll measure it with the meter. And so here we see 1.018 or 17 megohms on the multimeter. And remember, these are plus or minus 5%. So they're quite accurate according to their value in ohms. That's the end of our resistor